In this lesson, we're going to focus on verifying hyperbolic identities. So here we have hyperbolic cosine plus hyperbolic sine equal to e to the x. How can we prove that? By the way, before working on these problems, I recommend watching a video entitled Hyperbolic Trig Identities, where I give you a list of formulas that you want to be familiar with. Using those formulas, you can solve problems like this one. So if you haven't seen that video, and if you don't have a list of hyperbolic identities in front of you, you may want to watch that video and write down those formulas. So let's go ahead and begin. In order to verify this identity, we need to convert cosine and sine into their exponential form. So hyperbolic cosine is equal to e to the x plus e to the negative x divided by 2. Hyperbolic sine is equal to e to the negative x minus e to the negative x over 2. Now, because we have common denominators, we can combine it into a single fraction. So e to the x plus e to the negative x plus e to the x minus e to the negative x over 2. E to the negative x and negative e to the negative x, we could cancel them. 1 e to the x plus 1 e to the x, that's going to be 2 e to the x. 2 divided by 2 is 1, so we get e to the x is equal to e to the x. So that's how we can verify this particular hyperbolic identity. Now let's try another one that's very similar to that one. Hyperbolic cosine of x minus hyperbolic sine of x. Let's prove that this is equal to e to the negative x. So we could use the same formulas like we did before. Cosine, hyperbolic cosine, is going to be e to the x plus e to the negative x over 2. Hyperbolic sine is going to be e to the x minus e to the negative x over 2. But this negative sign will have to be distributed. So let's combine it into a single fraction. Since we have common denominators, this is going to be e to the x plus e to the negative x, and then negative e to the x. And then these two negatives will cancel, giving us positive e to the negative x. E to the x and negative e to the x will cancel. These two, we can add them together, and we're going to get 2e to the negative x over 2. And then we could cancel the 2's, giving us e to the negative x. So that's how we can verify that particular identity. Now let's try this one. Let's verify the double angle formula of hyperbolic sine. So we know hyperbolic sine of 2x is 2 times hyperbolic sine of x times hyperbolic cosine of x. How can we verify this particular identity? We need to use the sum and difference formulas. Hyperbolic sine of x plus y is equal to 2 sine, actually not a 2. It's hyperbolic sine of x times hyperbolic cosine of x plus, if we see a plus here, this is going to be a plus. And then this should be a y, not an x. And then plus hyperbolic cosine of x times hyperbolic sine of y. Using this formula, we can prove it. What we need to do in order to get 2x is we need to replace y with x. X plus x is 2x. So this is going to be x plus x. So in this formula, everywhere we see a y, we're going to replace it with an x. So we don't need to change sine of x. Cosine y, that's going to become cosine x. and hyperbolic sine of y is going to be hyperbolic sine of x. Now notice that these two are the same. Sine times cosine is the same as cosine times sine, so we could simply add the coefficients. This has a 1, this has a 1. 1 plus 1 is 2. So we get 2 sine times cosine. And on this side, x plus x is 2x. So that's how we can prove the double angle formula. It's by using the sum and difference formulas for the hyperbolic function identities. Let's try another similar one. So hyperbolic cosine of 2x. Let's prove that it's equal to hyperbolic cosine squared plus hyperbolic sine squared. So we need to know the sum and difference formula for hyperbolic cosine. And here it is. Hyperbolic cosine of x plus y is hyperbolic cosine of x times hyperbolic cosine of y, and then plus hyperbolic sine of x times hyperbolic sine of y. So in order to get 2x, we need to replace y with x. So instead of hyperbolic cosine y, we're going to write hyperbolic cosine x. And instead of hyperbolic sine of y, we're going to write hyperbolic sine of x. So that's what we've done so far. We just replaced y with x. Now x plus x, we can make that 2x. Cosine times cosine is cosine squared, and sine times sine is sine squared. So that's how we can verify the double angle formula for hyperbolic cosine. Now let's try this one. Go ahead and verify that hyperbolic sine of negative x is equal to negative hyperbolic sine of x. Now we're going to use the sum and difference formulas for hyperbolic sine. So I'm just going to write the formula first. So hyperbolic sine of x plus y is going to be hyperbolic sine of x times hyperbolic cosine of y plus hyperbolic cosine of x times hyperbolic sine of y. Now, in order to get negative x, what should x and y be? Well, we want x at the very end, so we should keep x as x. Y, we want to make that negative 2x, because x minus 2x will give us negative x. So all we're going to do is replace y with negative 2x wherever we see it. So this is going to be hyperbolic sine of negative 2x. So x minus 2x is negative x. We're going to keep hyperbolic sine of x. Now what can we do with this? Hyperbolic cosine of negative 2x. Now recall the even identity of hyperbolic cosine. Hyperbolic cosine of negative x is the same as hyperbolic cosine of x. So hyperbolic cosine of negative 2x should be the same as hyperbolic cosine of 2x. Hyperbolic sine of negative 2x. Now, we know this identity to be true, but we're trying to prove it, but we can still apply it. This is going to be negative hyperbolic sine of 2x. Now, hyperbolic cosine of 2x, we could use the double angle formula for that. And that is cosine squared plus sine squared. So cosine squared of x plus sine squared of x. And here we have negative cosine of x, and then we can use the double angle formula for sine. That's going to be 2 sine cosine. So now let's see what we can do here. Let's distribute sine. So we're going to have sine of x times cosine squared. And then here, this is just going to be sine cubed. And for this one, we have negative 2 sine times cosine squared. Now, these two expressions, we can combine them. So this is 1 minus 2, and it's going to become negative 1. So right now, we have sine cubed, and then minus sine cosine squared. What I'm going to do is I'm going to factor out a sine. So I'm going to be left with sine squared and then minus cosine squared. Now, what is sine squared minus cosine squared? What can we do with that? If you recall, for trig functions, cosine squared plus sine squared is 1. For hyperbolic functions, cosine squared minus sine squared is 1. So what I'm going to do first is I'm going to factor out a negative 1. Negative cosine becomes positive cosine, and I'm going to write that first. Positive sine squared will become negative sine squared. And this is one of those identities that you need to be familiar with. This one equals 1. So we have a negative 1 in front, or at least I'm going to move it to the front. And this part equals 1. So thus we have hyperbolic sine of negative x, there should be an h here, is equal to negative hyperbolic sine of x. So at least that's one way we can prove it. Now let's move on to our next example problem. Cosine squared of x minus hyperbolic sine squared of x is equal to 1. Go ahead and verify that identity. Now what we need to do is convert cosine and sine into their exponential form. Cosine is e to the x plus e to the negative x divided by 2, but it's squared. Sine is e to the x minus e to the negative x divided by 2. So what we need to do is we need to FOIL. So I'm going to rewrite it first. We have e to the x plus e to the negative x. It's squared. So we're going to multiply it by itself. And then 2 squared, that's 2 times 2. That's simply 4. Here we'll have something similar. Over 2 squared, which is 4. E to the x times e to the x, that's going to be e to the 2x. And then multiplying those two together, e to the x times e to the negative x plus negative x is 0, so we get e to the 0. These two will also give us e to the 0. And negative x plus negative x, that's negative 2x. Now, because we have the same denominator, we can combine it into a single fraction. Now here we have e to the x times e to the x, that's e to the 2x, but we have a negative in front, so I'm going to distribute that negative sign. These two, e to the x and e to the negative x, the exponents x plus negative x adds up to 0, so we get e to the negative x. We have a negative sign here plus the negative sign in front, so it's going to be positive e to the 0. As for these two, the exponent will be 0, so that's another e to the 0. This is negative, that's negative, so it's going to be positive e to the 0. And then these two here, negative x plus negative x, that's going to give us an exponent of e negative 2x. These two negative signs make it positive, plus the third negative sign makes it negative overall. So now e to the 2x will cancel with negative e to the 2x. Positive e to the negative 2x will cancel with negative e to the negative 2x. And we have 4 e to the zeros. Anything raised to the 0 power is 1. And 4 divided by 4 is 1. So that's how we can verify this particular hyperbolic trig identity. Now let's try another one. 1 minus hyperbolic tan squared is equal to hyperbolic secant squared. Let's verify that. Now hyperbolic tangent is hyperbolic sine over hyperbolic cosine, but in this case it's going to be squared. Secant is the reciprocal of cosine. So secant squared is 1 over cosine squared. Actually, let's keep this as secant. Now I want cosine squared on the bottom. And we have two terms. We need to make it a single term. So let's multiply 1 by cosine squared over cosine squared. This will give us common denominators. So now that we have common denominators, we can combine the two fractions into a single fraction. So we're going to have cosine squared minus sine squared all over cosine squared. Now from the last example, we saw that cosine squared minus sine squared, that is equal to 1. So now we have 1 over cosine squared is equal to secant squared. And 1 over cosine is secant, so we have secant squared is equal to secant squared. So that's it for this verification. Now let's try another problem. go ahead and verify this identity. 1 plus hyperbolic tangent divided by 1 minus hyperbolic tangent is equal to e to the 2x. Now, 1, I'm going to multiply by cosine over cosine, but particularly hyperbolic cosine. So 1 can be replaced with hyperbolic cosine over hyperbolic cosine. Tangent is sine over cosine. So we're going to have hyperbolic sine over hyperbolic cosine. Now, what do you think we need to do next after this? Notice that each of these 4 fractions have the same denominator. So we're going to multiply every term by cosine. So each denominator will be canceled. Actually, let's keep that. So we're going to have hyperbolic cosine plus hyperbolic sine divided by hyperbolic cosine minus hyperbolic sine. Now, if you've seen my video on hyperbolic trig identities, it's important to know that e to the x is cosine plus sine. So we can replace this with e to the x. You can also replace cosine with e to the x plus e to the negative x over 2. You could do it that way as well. But just in case you didn't know that this was equal to e to the x, we'll do it using the more commonly used functions. So I'm going to replace cosine with e to the x plus e to the negative x over 2, and then sine with e to the x minus e to the negative x over 2. So multiplying the top and bottom by 2, all the 2's will be canceled. So that's what we have in the numerator, and in the denominator we have e to the x plus e to the negative x. Here we need to distribute the negative, so it's negative e to the x. These 2 negatives will cancel, giving us positive e to the negative x. E to the negative x will cancel here, and e to the x will cancel. So e to the x plus e to the x, that's going to be 2 e to the x. And then e to the negative x plus e to the negative x, that's 2 e to the negative x. 2 divided by 2 can be canceled to 1. So we're left with e to the x over e to the negative x. And when you divide by a common base, you need to subtract the exponents. So we're subtracting positive x by negative x, which becomes, the 2 negative signs will make it positive. So x plus x, we get e to the 2x.